Hello everyone, welcome back to my YouTube channel. Today we are going to see class 10 science 2 chapter number 5, and this is a part 2 we are going to discuss. In a part 1 already we have discussed about different kind of the power plants, and the problem was that kind of power plants are nothing but they are producing a lot of pollutions which is not environmental friendly. In this particular section, today's section, we are going to talk about the power plants which are less harmful to the environment, or in some cases they are zero pollutants and the environmental friendly power generators. In that, the first we are going to talk about the hydroelectric energy, or the hydroelectrical energy power plants. In this, what actually we are doing, the reservoirs are made, and in that reservoirs the water is stored in a large quantity, and that stored water is passed over the turbines. To rotate that turbines, the current of water is used from this reservoirs, and then after the rotation of the turbine, as we know, all the power plants are having a similar concept, that is a water turbine, generator, and then the electrical energy is produced with the help of that. Further, the next another what we can have is the electric generator, or the schematic diagram they have given over here. The potential energy in a water that's get converted into a kinetic energy, then the kinetic energy in a turbine, and then the electrical energy. They have shown over here this particular figure, or this particular diagram they have shown. See, in the reservoir water is stored in a large quantity, and it is passed through the canal, and the turbines are rotated with the help of this current of water, and then this turbine is connected to the generator, and then that produces the electricity. Further, when we talk about the advantages of the hydroelectric power generation, since no fuel is burnt in this hydroelectric power generation, there is no pollution, no air pollution. If there is a sufficient water storage in the dam, it is possible to generate electricity as and when necessary. Then, although water reservoir is used for power generation, it can be replenished during rainy season, leading to uninterrupted power generation. What are the problems associated with it? The backwater, due to storage of water in dam, may submerge villages or towns in that area. This leads to the problem of rehabilitation of the displaced population. Moreover, this can also submerge a forest as well as a fertile land. So that is the one big issue we have. The obstruction of the flow of river water may have adverse effect on living world in the river after the dam. Further thing is, they have given over here some information regarding some important hydroelectric plants in India. The one they have given as a Tehri in Uttarakhand, which produces 2,400 megawatt, and the Koyna in Maharashtra, 1,960 megawatt. Then the Sri Salam in the Andhra Pradesh, 1,670 megawatts, and then the Nathpa Chakri in the Himachal Pradesh, which produces almost 1,500 megawatt as energy. The next what we have to study is wind energy, electrical generation using the wind energy. That is also what the similar kind of that the turbines are connected with the shaft, and then the shaft is connected to the blades of the windmill. So this windmill blades are rotated when there is a wind in the ground, and then that rotates the turbines, then the gearbox, generator, and that produces the electricity. Kinetic energy in wind, that's converted into a kinetic energy in turbine, and then produces the electrical energy. Further, when we talk about this particular section, you can see here the blade length, home, wind farm, and then the offshore wind turbine. And these blades, they are producing the good amount of electrical energy. Further, that is electrical energy generation using solar energy. In the solar energy, when we talk about the solar photovoltaic cells are used in that. The sun is one of the great source of energy. Solar photovoltaic cell converts the solar radiation energy directly into electrical energy. This is called solar photovoltaic effect. The electrical energy generated through the energy transformation process in DC in nature, these solar cells are made of a special type of material called semiconductor. For example, silicon is used. Silicon solar cells of dimension 1 centimeter square generates current of about 30 milliampere and potential difference of about 0.5 volt. Thus, a silicon solar cell of dimension 100 centimeters square will generate about 3 ampere and 100 centimeters square 3000 milliampere and current and 0.5 volt. Remember that the potential difference available from a solar cell is independent of its area. So potential difference is not changing, only the current what is generated with the help of a solar panels is changing. So photovoltaic effect that energy in a sunlight is converted into a DC electric power. If solar cells are connected in series, then the potential difference obtained from the combination is addition of the potential differences of individual solar cells. However, the current generated from the combination is equal to the current from an individual cell. You can see over here, if the cell 1, cell 2, potential difference will get added up and current remains the same. And if they are connected in a parallel combination, then the current will get added up on the potential will remain same. So here in this case, the arrangement of the solar panel cells are like this. Some are in series and some are in a parallel. Further, the module cells in series and strings in parallel. You can see here the module cells in series and then the string of this modules are connected into a series or the parallel. Further, they have given us about a solar cell is storing energy into a battery to the inverter, and an inverter converted into the electric equipment working on AC. Then here they have given the arrangement, the schematic representation. You can see the solar panels are there and they are connected to the transformer, and then transformer and the inverter converts that into the AC signal, and then that is passes wherever it is required. Solar thermal power plant concentrates for collecting sunlight, and then the absorber for absorbing the concentrated sunlight, and then that will be used to boil the water, and then the steam is passed over the turbine to rotate it, then the electrical generator, and then the electrical energy. Further is in this particular section, as shown in the figure 5.3, many reflectors reflect and concentrate solar energy or the solar radiations on absorber. Their solar energy is converted into heat energy. Using this heat energy, steam is generated to drive the turbine and generator. You can see over here this solar panels. The solar panels are nothing but what the concentrator that concentrate the energy, and the water pipes are passed over it. This reflects lights on this particular pipes. So as the temperature increases and that's get boiled and the steam is passed, and then that steam is used as a normal process. So energy sources for the electrical power generation in the world and in India they have given in this particular chart. Coal in a word, it is a 41%, in our country it is a 60%. Natural gas 22 and here 8. Hydroelectric, that is the 16, and in India it is a 14%. Then the nuclear energy, it is 11 and 2% in India. Petroleum 4% in the world and the 0.3% in the India. And then the renewable sources, wind, solar and all that 6%, and in India it is used as a 15.7. So if you will see in our country, almost 40% energy comes from different sources and 60% from the coal. So this is the difference we have in the world and the India. So if, but the important factor what we have to discuss over here is the renewable sources. In India, we are having almost a 16% energy from the renewable sources, whereas in the world only 6% is from the renewable sources. So in that section, India is well ahead of the world. So this is all about energy and the chapter number 5.